Hello, my name is Jared Skeens and welcome to Quick Fix. Today we want to look at IGCSE year 2020, the May-June series of 2020, paper 43. We're going through the worked solutions. And again, if this is your first time or even if you've watched these before, the goal is not just so that you have an answer on your paper. The goal is that you understand what you're doing. So again, focus on how to set up the problem, what ways to think through the problem, and then of course, getting the right answer at the end as well. So let's get started. Here we go. Number one has campsite fees per day. Tent is $15, caravan is $25. So it says the sign shows the fee charged at the campsite. Today there are 54 tents and 18 caravans on the site. Calculate the fees charged for today. So there's 54 that have tents. The tents are $15 plus 18 that have caravans. Caravans are $25. So for the tents, you get 810. For the caravans, you get 450. You add that together and you get $1,260. Part B, in September, the total income at the campsite was $37,054. This was a decrease of 4.5% on the total income in August. So when you have percent decrease, you're gonna subtract, because it says decrease, and you're going to subtract it from 1 and you're going to get 0.955. Don't forget to change your 4.5 into a decimal and you get 0.955. And then read carefully, calculate the total income in August. So this decrease was a decrease of August's value. So we have 0.955 times August value, which I used in X, and that will equal $37,054, which is September's. So remember, you reduce August and you get September's. So divide both sides by 0.955 and you get X being our September. September equals 38,800. I think back up here I said August. So this was a decrease of September's month to get August's value. And so our total income in August was 38,800. Letter C, the visitors to the campsite today are in the ratio of 5 to 4 for men to women, 3 to 7 for women to children. Whether or not you need these numbers, I always like to put a total when I'm working with ratios. So a total here is 9, a total here is 10. Calculate the ratio of men to women to children in its simplest form. Well, our men to women was 5 to 4, and our women to children was 3 to 7. Well, since we have women on the bottom over here on the left, we're going to put women on the bottom over here on the right. So we have men to women, 5 to 4. And then over here, we're going to put children to women. That way the women occupy the same location in the fractions. And now that we have the women in the same location, we're going to get a common denominator, which will be 12. So the fraction on the left, we multiply top and bottom by 3. The fraction on the right, we multiply top and bottom by 4. So we get 15 twelfths to 28 twelfths, the 12 being the women. So 15 men to 12 women to 28 children. Then today there are 224 children at the campsite. Calculate the total number of men and women. So men and women being all the adults. So if we look at the children compared to the adults, it's 28 to 27. When you add 15 and 12, you get 27. And then we set that equal to the number of children total is 224. We want to find the total number of adults, cross multiply, divide by 28. And so there are 216 adults. So 216 adults with that. Letter D, the space allowed for each tent is a rectangle measuring 8 meters by 6 meters, each correct to the nearest meter. Calculate the upper bound for the area of space allowed for each tent. So this is an upper lower bound question. The first thing you need to do is find the upper and lower bound of each individual measurement. They are correct to the nearest meter. That means we take a half meter above and below. So we get 7.5 is the lower boundary, 8.5 is the upper boundary for this measurement. Then for the 6, 5.5 and 6.5. Calculate the upper bound for the area. So area is length times width. And so since it wants the upper bound, we will take the upper values. So 6.5 times 8.5, which gives us 55.25 meters square. Letter E, the value of the campsite has increased exponentially by 1.5% every year since it opened 30 years ago. So here's our increase by percent. So we have 1 plus, and change your percent to a decimal, 0.015. That equals 1.015. This is exponential growth, meaning you follow your compound interest formula. It's the same formula. And calculate the value of the campsite now as a percentage of its value 30 years ago. So we want to find the value of it now equals its original value, which we don't know. So we just put original here. Amount after time equals original amount. And then times the rate is the 1 plus 0.015, which is 1.015, raised to the time, which is 30 years. Now, it might make you a little nervous because you have two unknown variables with just one equation. Don't worry about it. Keep working with what you have. So when you take 1.015 raised to the 30, you now have your amount after time is equal to 1.563 times the original amount. Now, the key to this is it's a percentage of the original. So we take our amount now, which is 1.536 a to the original amount, and we divide it by the original amount because it's a percentage of the original. So in this case, our original amount cancels out. We're left with 1.563. Move the decimal over twice to change it into a percent. And that is what we have now. It says calculate the value as a percentage of, so it's 156%. That's the three significant figures of the original value that it had 30 years ago. Now we get into transformations. So our first question here is draw the image of A after a reflection in the line y equals negative x. So right through here is our line y equals negative x. It crosses the y-axis at an understood 0, has a -1 slope, so down 1 over 1, and you can see this is the y equals negative x. We want to reflect A over this line of symmetry. So what you do is you count perpendicularly to the line and then count the same on the other side. So here's our vertex. So if we go perpendicular, it would be diagonally. So here's one complete diagonal and a half before we reach the line. So we need to go 1.5 on the other side. So here's the half and here's 1. So here's the dot that corresponds, or the vertex that corresponds to this one right here. If we come up to this one, we go 1, 2, 3, 4.5. Here's 1/2, 1, 2, 3, 4. So here's our dot here. Do the same thing over here, 1, 2, 3.5. So here's a half, 1, 2, 3. And here's our vertices. and we make our triangle, and this is I. Then for AII, draw the image of triangle A after a translation by the column vector -2, -9. So basically we start at our vertex, we go back 2 for the X, down 9 for the Y. 1, 2, 3, 4, 5, 6, 7, 8, 9. There's this dot here, go back 2, down 9, you get here. From this one, go back 2, down 9, and you get here. So this is AII. Then describe fully the single transformation that maps triangle A onto B. So A onto B, obviously it's not just a translate, it's not a rotate, and it's not a reflection. This is an enlargement. Even though it's getting smaller, it's still called an enlargement. So that's the type. Then we need the scale factor. So if you look at the original length is 4, the corresponding image length is 2. So we went 4 down to 2. In other words, we have 1/2 of the original. So the scale factor is 1/2. Then we need to find the center of the enlargement. You take your corresponding vertices, draw a straight line through it. Find another pair of corresponding vertices, draw a straight line through it. Where those lines intersect is your center of enlargement. So it's at -7 and 8. So the answer for all 3 points, enlargement, scale factor 1/2, and a center of -7, 8. Now we want to describe triangle A onto triangle C. So A onto C, hopefully you notice that it rotates going here to the right. So the first part of the answer is rotation. The second part of the answer is 90 degrees clockwise. 90 degrees clockwise, so you have to say how much it rotates. Then we need our center of rotation. So what you want to do is make a 90-degree angle between any corresponding vertices. So if you look at where that 90-degree would be, the center is right at the origin. So rotation clockwise 90 degrees with the center at 0, 0, or you could say center at the origin. Number 3, here's some information about the masses of potatoes in a sack. The largest potato has a mass of 174 grams. The range is 69 grams. The median is 148 grams. The lower quartile is 121 grams. The interquartile range is 38 grams. On the grid below, draw a box and whisker plot to show this information. Well, for a box and whisker, you need what's called your 5-number summary. You need the minimum, the first quartile, the median, which is the same thing as second quartile, third quartile, and then the maximum. So it gives us the largest, that's the maximum, and it gives us the range. So if we take the maximum minus the range, that will give us the minimum. So the minimum is 105. Notice here it's plotted. Here's 100, here's 110, 105 is right there. So put a dot. And then we need the first quartile. The lower quartile, which is same thing as your first quartile, or Q1, is 121. So here's 121, there's a dot. And then the median is 148. So come over here to find 148, there's a dot. And we need to find the upper quartile. It gives us the interquartile range. So if we have the lower quartile and then we add the interquartile range, Q1 plus the IQR, interquartile range, will give us Q3, which is 159. So here we see the 159 right here, and the maximum was 174. So there's our 5-number summary. It's a box and whisker. So make sure you have whiskers on the outside end and make a box with the 2 middle sections. Okay, that's our box and whisker. The table shows the marks scored by some students in a test. Calculate the mean mark. Well, the mean is just frequency times your score. So 8 times 5 plus 2 times 6 plus 12 times 7 plus 2 times 8 plus 0 times 9 plus 1 times 10 all divided by the total, which there's a total frequency of 25. So you get 162 over 25, which is an average score of 6.48. Moving on, number 4A, solve the inequality. So here we want to, I prefer to get the variables on the side so that the variable is positive. So I'll subtract 3m from both sides, get 12 less than or equal to 5m minus 5. Since my m's are on this side, I need to move the numbers to the left, add 5, get 17 less than or equal to 5m. I just flip that thing around so that my variables are in the front. Think a little bit easier that way. Divide both sides by 5. M is greater than or equal to 17/5. Letter B, solve the equation 2x plus 5 over 3 minus x equals 14 over 15. This is a proportion, two fractions set equal to each other. All you have to do is cross multiply. So 15 times the 2x plus 5 equals 14 times the 3 minus x. Distribute through the parentheses, you get 30x plus 75 equals 42 minus 14x. Get your variables together, so add 14x to both sides, you get 44x plus 75 equals 42. Subtract the 75 from both sides, and then divide by the 44. And your fraction reduces. You can divide top and bottom by 11. So your x equals a negative 3/4. Letter C, solve the simultaneous equations. You must show all of your working. Here we have a linear equation, y equals 4 minus x. And we also have a circle here. Actually, that's not a circle, that's an ellipse. So we have an ellipse, but that's okay. You don't have to know the shapes. You're given the equations. What is important though is because this first one is linear and this second one is a type of quadratic, it's a conic section. Like I said, it's an ellipse. The power is 2, so you can't use elimination with this setup. You can't use a square to eliminate a single power. So we have to use substitution. The y is already set here. Just plug it into the second equation. So we get x squared plus 2 times 4 minus x quantity squared equals 67. Multiply out your quadratic here. Remember, exponents do not distribute across to add and subtract. You have to take 4 minus x times 4 minus x and then do the smiley face method. So you get 16 minus 8x plus x squared, distribute your 2. Then we want to combine like terms. So our 2x squared and x squared make 3x squared minus 16x plus 32 equals 67. Since this is a quadratic also, it's a different quadratic. This is a parabola. We want to move the 67 over here, get everything set equal to 0. Then we factor. The factors of 3 are 1 and 3. The factors of 35 are 5 and 7. That is what gives us a combination of 16 in the middle by subtracting. So 3 times 7 is 21. 21 minus 5 is our 16. And we want the 21 to be negative. So we'll put the negative on the 7, the positive on the 5. So we have 3x squared. Here's our minus 35. Here's our negative 21 plus 5 is negative 16. So our two answers for x are negative 5/3 and 7. Plug those into either equation. Of course, the y equals 4 minus x is the more simple equation. Plug those in there, solve those for y. So for the 7, you get a corresponding y of negative 3. For the negative 5/3, you get a corresponding y value of 17/3. Moving on to number 5, all lengths in this question are in centimeters. Here it gives you this box with algebraic expressions for the lengths. So we have 2x along here, x plus 1 here, 4x minus 5, and x plus 3. So there were two sides that did not give us an expression. So if we take the total width and minus the part over here, 2x minus the x plus 3, we can figure out this piece right here. Don't forget to distribute the negative. And so we end up with x minus 3 for this section from E to F. Also from E to D, we take the total length for x minus 5, subtract the x plus 1. Again, don't forget to distribute the negative, combine like terms, and you get 3x minus 6 for the E to D mark. The diagram shows a shape A, B, C, D, E, F made from two rectangles. The total area of the shape is 342 centimeters square. Show that x squared plus x minus 72 equals 0. Well, it's given you area. So when you're calculating area, you do this width times length of each of these rectangles. So for the small rectangle, the width is x plus 1, and the height we calculated as being x minus 3. So x plus 1 times x minus 3 plus this bigger rectangle, which is x plus 3 here on the side, and 4x minus 5 long. Multiply both of those out, and you get x squared minus 2x minus 3 plus 4x squared plus 7x minus 15. All of this area equals 342. Again, since you have a quadratic in there, get everything on one side and set equal to 0. And you end up with 5x squared plus 5x minus 360 equals 0, which you can reduce by dividing everything by 5, giving you x squared plus x minus 72 equals 0, which is exactly what they wanted you to get. Then we want to solve that by factorizing. The factors of 72 that come up to 1 by subtraction are 8 and 9. And we want the 9 to be positive and the 8 negative. So 9 minus 8 is a positive 1. Solve both of those, you get x equals negative 9 and x equals 8. Now we'll come back to this right here. It says work out the perimeter of the shape of A, B, C, D, E, F. We want the perimeter. Notice it's got all these x's in here. Well, we can't use the negative 9 because if we put the negative 9 in, we would have a negative length. We can't have negative length. So that's why it says this cannot equal negative 9, both because of the length as well as the area. You can't have negative area either. So we are going to use the 8, plug it into these different lengths because we're going to do perimeter. So 8 plus 1 is 9, 2 times 8 is 16, 4 times 8 is 32 minus 5. Here we have 8 plus 3, and go around there, and you're going to end up with these numbers on the outside. So you have 16 plus 9 plus 5 plus 18 plus 11 plus 27, and those add up to 86. I'm not sure why I had put 89 there, but I fixed it for you. So it says 86. Calculate angle DBC. So DBC, you can draw the line in there so that you can see the angle. D to B to C. And notice this is a right triangle. So we're going to use Sekolah. So from our angle, the 11 is opposite and the 27 is adjacent. So it's going to be tangent from our Sekolah. Tangent theta equals 11 over 27, inverse tangent both sides, and you get 22.166. With Cambridge, you go to a 1 decimal for degrees. So 22.2 degrees. Number 6, here we have this diagram with angles. The diagram shows triangle ABC with point G on the inside. CB is 11, see that right here. CG is 5.3, BG is 6.9, angle CAB is 42, angle ACG is 54, and it wants us to calculate the value of X. Well, if you notice, X is on this little triangle that is not a right triangle, and we have all 3 sides, and we have no currently existing angles. So what we can do is we want to find angle X here. So the opposite of angle X is the 6.9. So we're going to do 6.9. We're going to use the law of cosines, by the way. This is the law of cosines. So the side that's opposite the angle that we're using or that we're looking for, 6.9 squared equals 5.3 squared plus 11 squared minus 2 times 5.3 times 11, and then cosine of the angle that we're dealing with, which is X. So as we do all the squares, you get the second line. Then we combine these two right here by addition. Be careful not to subtract the 116.6 from the 149.09. You cannot do that because this is a multiply over here next to the cosine, and multiplication has to be before the subtraction. So we're going to instead subtract this over to the other side, the 149.09, subtract it from 47.61. You get a negative 101.48 equals negative 116.6 cosine X. Divide both sides by that negative 116.6. That is what undoes the multiplication. The opposites divide, and you get cosine X equals 0.870325. And then take the inverse cosine of that and you get 29.5 degrees. It also says to calculate AC. And with AC, we can use this big triangle here. And notice now that we have 54 and 29.5 and we got this 42 down here, we can calculate that the missing angle is 54.5. So this big angle right here is 54.5. We took 180 for a whole triangle, minus the 42, minus the 54, minus the 29.5, and we get 54.5. So now we have all three angles and one side. So now we can use the law of sines. It wants us to find AC. So 11 over the sine of 42, notice the 11 is opposite to 42, is equal to AC over sine of 54.5. So the length AC that we're trying to find is opposite this 54.5. And what we're solving for is AC, so just multiply the sine 54.5 to the other side. Simplify all this on your calculator. Make sure your calculator is in degree mode, and you get AC equals 13.38 or 13.4 to 3 significant figures. Part B here is this three-dimensional diagram, and we have water flowing at a speed of 20 centimeters per second along this rectangular channel, and then it goes off into a lake. The width of the channel, you can see here, is 15. The depth of the water, not the channel, but the water itself, depth is 2.5. So we take 2.5 times the 15 to get the area of this little slice of water there, get 37.5 centimeters square. Multiply that by the rate at which the water is going past this, this particular cross section. And when you multiply by 20, you get 750 centimeters cubed per second. And it wants us to figure out how many liters in 1 hour. So we take our seconds, we have to multiply by 3,600 seconds in 1 hour. That's 60 times 60. 60 seconds per minute, and then 60 minutes per hour. So that gives us 3,600 seconds for 1 hour. So the seconds cancel out. Multiply this together, we get 2,700,000 cubic centimeters per hour, but it wants the answer in liters. So 1 liter is 1,000 cubic centimeters. And so 3 zeros cancel off from that, giving us 2,700 liters per hour. Here's a probability question for number 7. On any Saturday, the probability that Arun plays football is 3/4. So here's Arun. The probability that he plays is 3/4. Remember, any particular branch set has to add up to 1. So 1 minus 3/4 means there's a 1/4 chance that he does not play. Then on any Saturday, Bob has the probability that he plays football 2 out of 5 Saturdays. So here is the probability that he plays. Again, 1 minus that, because every branch set has to add up to 1, has to represent 100% of the probability. So 1 minus 2/5 is 3/5 chance that Bob does not play. Okay. And that would be true regardless of whether Arun plays or does not play. So we continue that same set of numbers for down here. Calculate the probability that one Saturday Arun and Bob both play football. So we want both of them playing. That's these two numbers along this pathway. 3/4 times 2/5 is 6/20. You can either leave it as 6/20 or you can reduce it to 3/10. Calculate the probability that one Saturday either Arun plays football or Bob, but not both. So if Arun plays, that's 3/4, but not Bob, would be times 3/5. If Arun does not play, but Bob does play, it's 1/4 times 2/5. And we cannot have them both playing together, and we cannot have them both not playing. So play or not play, play for Arun, not play for Bob, or not play for Arun and play for Bob, gives us 3/4 times 3/5 for Arun, which is 9/20. 1/4 times 2/5 for Bob, which is 2/20. And you add those together and you get a chance 11 out of 20 chance that either one or the other is playing, but not both. Calculate the probability that Bob plays football for 2 out of the next 3 Saturdays. Well, out of 3 Saturdays, we've got 3 different scenarios here. Bob could play, because we only need 2 of the 3. So play, play, not play, or play, not play, play, or not play, play, and play. So here are 2 out of the 3 Saturdays, but in different sequences. So there's a total of 3 sequences. And so the probability of playing is 2/5 times another probability of playing is 2/5 times a probability of not playing is 3/5. All of that multiplied by 3, because there's 3 different arrangements of those values, 3 different ways that that can happen. Multiply by 3 and you get 36 over 125 as your probability. Part C, when Arun plays football, the probability that he scores the winning goal is 1/7. Calculate the probability that Arun scores the winning goal on a particular Saturday. So first of all, in order to score a goal, Arun has to play. So that's 3/4 right there. And then multiplied by the probability that he scores the winning goal when he plays football. So that's going to be times 1/7. That gives us a total of a 3/28 chance that he would score a winning goal on any particular Saturday. Here's 8A, the interior angle of a rectangular polygon with insides is 150 degrees. Okay, so this is interior angles of a regular polygon. Your formula for that is n minus 2 times 180. This is the total of interior angles for any regular polygon or any polygon, n minus 2 times 180, where n is the number of sides. Now, this doesn't give you the total angles. It gives you one interior angle is 150 degrees. So we have to divide the total by the number of sides, which is the same as the number of angles, to get one specific angle. So this is our formula. Multiply n to the other side to get rid of the fraction. Distribute the 180 through the parenthesis, gives you 180n minus 360 equals 150n, because we multiplied this n over here. Now just combine like terms, subtract the 150 and add the 360 to the other side. So 180 minus 150 is 30. Divide both sides by 30. So that means n equals 12. It is a 12-sided polygon where one of the angles is 150 degrees. Part BI, we have this diagram here on the right. L, M, and or K, L, and M are points on the circle. K, S is tangent to the circle at K, and KM is the diameter. And also triangle KLM is isosceles, meaning that two sides are equal. Find the value of Z. Well, one thing that you should know is when you have a tangent to a diameter, it's perpendicular. So that gives us 45 here. Another thing that you can look at is you have an inscribed angle that opens up to the diameter. Inscribed angle that opens up to the diameter is a 90-degree angle. Okay, so if we take 180 minus 90, that means 90 left, and these two sides are the same, which means these two angles are the same. So we take the 90 divided by 2, that gives us 45 each. So there's a couple of ways that you can get this. You can get it by working through this inscribed angle that opens up to the diameter, or you can get this perpendicular down here because it's a tangent to the diameter. So that's perpendicular. And we already know that this top one is 45 by working through this over here. So 90 minus 45 also gives you 45 for Z. Part IIAT, again, is tangent to the circle. Find the value of X. So here's X up here. Here is our 58. Notice this 58 is along the tangent and over to here. That means this arc right here is 58. And if you notice, this inscribed angle also opens to the same arc here. So an inscribed angle is, both of these are inscribed angles that open up to the same arc. So this inscribed angle is on a tangent to this chord, and this inscribed angle is on this part of the circle and just opens up directly to the same arc here. So if this is 58, that means this is 58. Here now is a triangle. 180 minus the 58 plus 27 gives us 95 for this one right here. This is a straight line, they're supplementary. So again, 180 minus the 95 gives us 85 for the X. So again, when you get into these kind of complicated diagrams, it's not what you're looking at. You know, don't worry about the complexity of the diagram. It's what are you looking for? So you're looking for diameters, you're looking for tangents, you're looking for inscribed angles, you're looking for cyclical quadratics, or quadrilaterals, I guess, cyclical quadrilaterals, which we don't have on this particular one. And so you find the pieces of what you're looking for, and eventually you work around to the unsolved one. Here we have our cyclical quadrilateral. Notice all 4 points are on the circle, and it's a quadrilateral here. So if we start with this 108, we have a straight line that gives us 72. And because these are parallel lines, alternate interior angles are equal. So two parallel lines cut by a transversal means this angle is equal to this one over here. which also means this one is equal to that one, or just subtract 180 minus 72 is 108. Now, because this is a cyclic quadrilateral, it means opposite angles add up to 180. So 180 minus the 108 gives you 72 for the value of y. Here's C. It says A, B, C, and D are points on the circle with center O. M is the midpoint of AB, and N is the midpoint of CD. OM and ON are equal. So notice OM and ON are equal. These are the midpoints. And so with giving reasons, explain why the triangle OAB is congruent to triangle OCD. So here we have, this is what I put. There may be more than one way of writing it out, but I put ON is perpendicular to CD. ON is perpendicular to CD because from the origin to the midpoint of a chord, it is 90 degrees. And then OC is equal to OD equal to OA equal to OB. So OC, OD, OA, and OB are all equal because they are all radii of, or radius of the circle, the radii of the circle. And then CD is equal to AB because ON is equal to OM, meaning it's the same distance away from the origin. And therefore, that means the chords are equal. Therefore, these two triangles are congruent. Okay, so because these two are equal, then that means the chords are equal. And because these chords are equal and they're cut in half, you can see here 1, 2s, and 3s, 1, 2s, and 3s as far as the hash marks of what's equal to what, and therefore congruent. Number 9, the equation of the line is, the equation of the line L is 3x minus 8y plus 20 equals 0. Find the gradient of the line. Well, we want to put this into y equals mx plus c format. So we move the 8y to the other side, divide by 8, so that gives us y equals 3/8x plus 20 over 8. And so the gradient, which is the slope, is 3/8. We can see that right here. 3/8 is our slope. Find the coordinates of the point where the line cuts or crosses the y-axis. Well, if you're on the y-axis, it means x equals 0. So we're going to plug in a 0 over here for the x. When I drew the line here, I'm just referring to the whole equation. So I changed it so it would look a little bit more clear. The 0 goes into the x. And when you put the 0 into the x, by the way, 20 over 8 reduces to 5/2. And when you plug in the 0, you get y equals 5/2. So your coordinates are 0 for the x, 5/2 for the y. Number 17, the coordinates of P are a -3/8, and the coordinates of Q are 9, -2. Calculate the length from P to Q. So we use our distance formula where we have our y2 minus y1 quantity squared plus, or I put the x's first, x2 minus x1 quantity squared plus the y2 minus y1 quantity squared, and you add them together and then square root it. So make sure you do not distribute your square root over add and subtract. You have to do the inside first. So 9 minus a -3 means 9 plus 3, which is 12, squared is 144. -2 minus 8 is a -10. I actually should put a -10 here, but because it's squared, I didn't. That's not really proper work. This should be a -10 squared, which is 100. 144 plus 100 is 244. And then the square root of that is 15.62. To three significant figures is just 15.6. For part II, find the equation of the parallel to PQ that passes through the point 6, -1. Well, we need to find slope. So we take -2, our change in y, -2 minus 8, that's our -10 on top, over change in x, which is our 9 minus -3 or 12 on the bottom. That reduces to a -5/6. This is parallel, meaning the slope is the same, but the y-intercept is going to be different. We need a point that is on the line, which is 6, -1. Be careful not to use these points. They are not on the parallel line. We need to use 6, -1. Plug that in for our x and for our y, and we come up with c being 4. So the total equation is y equals -5/6x plus 4. For part III, find the equation of the perpendicular bisector of PQ. So first, we already found the slope of PQ up here. It was a -5/6. Now we want the perpendicular bisector. So perpendicular means take the negative reciprocal. So change the sign and flip it over. So now we want y equals 6/5 x plus c. We need to find a point that is on this line. Since it is a bisector, that means it goes through the midpoint. So find the midpoint, add the two x's together, divide by 2, add the two y's together, divide by 2. 9 minus 3 is 6, divide by 2 is 3. 8 minus 2 is also 6, divide by 2 is 3. So we get the point 3, 3. We plug that in for our x and y so that we can solve for the c. The c ends up being a -3/5. So our perpendicular bisector is y equals 6/5 x minus 3/5. Number 10, the diagrams show the graphs of two functions. Write down each function. So here is a line. We know that that follows y equals mx plus c. We can see that it crosses the y-axis at 5. So that's +5. That's the c part. We also need the slope. So here we have 2 points on the line, and we count our rise over run up 5 over 5, which gives us a slope of 1. So the equation of this line, f of x equals x plus 5. Now down here we have a trig graph, and hopefully you recognize it as a sine function. This shape here is a sine graph. It's only one complete cycle within 360, so the coefficient of the x is just 1. The center line is 0, so there's no number to put in the front, and then the amplitude is 2, goes up and down 2 from the center line, so that is the coefficient of the sine x part. Then we go to this diagram here. Says the diagram shows the graph of another function. By drawing a suitable tangent, find an estimate for the gradient or the slope of the function at the point P. So here's the point P. It says by drawing a suitable tangent line means you're going to take your straight edge and you're going to move it right up to the point P so that you basically have the same distance and gap on both sides. Then you pick 2 points on the line, find the coordinates. So I found the coordinates 2, 2.7. That is this dot right here, 2.2 and 2.7 was the value for P. You can see right here, 2 and 2.7. And then the 0.5 and 0.8 are this point right here, 0.5 and 0.8. So we use our slope formula, change in y over change in x. I went this direction, 2.7 minus 0.8. So the change of x, I also have to go this direction, 2 minus 0.5. That gives us 1.9 over 1.5, which comes out to 1.26. So I rounded it up to 1.27. Now notice the window is very tight. The window of acceptable answers is 1.3 to 1.4. So notice I missed it just by a little bit, by 3/100ths. Cambridge would probably take off 1 point for this because I missed the window. I left it here just so that you could see that drawing a tangent isn't always easy. So for me, when I drew it, it looked pretty good. When I look at it now, when I see that I missed it by just a little bit, I think I would have moved this one up just a little bit. So just rotate that straight edge down just a little bit. Maybe I didn't quite get the same amount of distance on both sides here, and hopefully you can get an answer between 1.3 and 1.4. But this is still how you do it. Moving on to number 11, this is about functions. So f of x equals 7x minus 4, g of x equals 2x over x minus 3. Because there's a division, they have to give you the domain statement, x cannot be 3. Then you have this h function, which is x squared. So part A, find g of 6. So we take 6 and we plug it into the g, into the x's that are in the g function. So we get 2 times 6, which is 12, over 6 minus 3. And so 12 divided by 3 is 4. 4 is that answer. For part B, find, here's a composite function, f of g of 4. So first we start by putting the 4 into the g. So we do that, we replaces the x's with 4. That reduces down to 8. Then we take that answer and plug it into f. So f of 8 then equals 7 times 8 minus 4. 56 minus 4 is 52. Then find f of h of x, where they don't give you a number, just a variable. So h of x is x squared. Now we take the x squared and put it into the f. So we have 7x squared minus 4. Letter D, find f of x over 2 plus g of x. Give your answer as a single fraction in simplest form. So f of x is our 7x minus 4 over 2 plus g of x is 2x over x minus 3. We want it as a single fraction, so we want a common denominator. This fraction on the left needs multiplied top and bottom by x minus 3. This fraction on the right needs multiplied top and bottom by 2. Therefore, you get a common denominator of 2x minus 3. On the top, you need to multiply out your x minus 3 times 7x minus 4, which is 7x squared minus 25x plus 12. And then multiply the 2 times 2x and get 4x. And when you simplify that, combining like terms, you get 7x squared minus 21x plus 12 all over 2x minus 6. Part E, find the value when you take the function of x plus 2 and set that equal to negative 11. So we're putting x plus 2 into the function. So 7 times x plus 2 minus the 4 is equal to negative 11. So distribute 7x plus 14. I moved the minus 4 over to the other side. I guess you could add it all together at the same time. I just distributed and moved it over. So when you subtract, or sorry, when you add 4 to both sides, you get negative 7. Then you need to subtract the 14 from the 7 times 2. Subtract 14 to both sides, that gives you 7x equals negative 21. Divide both sides by 7, gives you x equals negative 3. Here's for the last one for this part. Find the values of p that satisfy h of p equaling p. So when you plug p into h, you get p squared, because your h is this, here's h up here, it's x squared. So when you plug in a p, you get p squared, and that needs to equal p. So when does p squared equal p? When I did it, I just kind of did it by recognizing the only two numbers that you can really square and get the same value. But then I went back and I did it algebraically for you so that you would see the work. Here we have a quadratic. So again, we're going to subtract p to the other side, set it equal to 0. Factor it. So you get p times p minus 1 equals 0. Then set each of these factors equal to 0, and you get 0 and 1. Number 12, a curve has an equation. Curve has an equation with y equals 4x cubed minus 3x plus 3. Find the coordinates of the two stationary points. So notice the stationary points are plural. There's more than one, and you're finding the coordinates, also plural, of those points. Now, stationary points, if you haven't learned, is if you have a curve, your stationary point is where the slope is equal to 0. So it's either going to be on the maximum side of a slope. It can also be underneath on the minimum side of a slope where the tangent slope is 0. So to find those, we do what's called the derivative. So for the derivative, you take the exponent, multiply it to the front, that gives us 12, and then you subtract 1 from the exponent, that gives us 2. Over here, we have an understood 1 times -3 is -3, and our understood 1 minus 1 gives us 0, which cancels out the x. Over here on the right, you learn that the derivative of a constant is 0. The reason being the exponent on your x, which you don't see, is an understood 0. 0 times the 3 cancels it out. So you have your first derivative, which is shown by y prime, is one of the ways of showing a notation for a derivative, is equal to 12x squared minus 3. You're going to set it equal to 0 because we want, at stationary points, the tangent line has a slope of 0, meaning the slope at that point is also 0. So our slope, which is first derivative, equals 0. We want to find out where. So 12x squared equals 3, divide by 12x squared equals 1/4. And square root both sides. Don't forget the plus or minus. So this is going to occur at 1/2 and -1/2. Now we need to find the y part of the coordinates. So we plug the x part into our original function. So 4 times 1/2 cubed minus 3 times 1/2 plus 3. Calculate all that out and you're going to get 2. If you plug in a -1/2 and calculate it out, you get 4. So 1/2 and 2 is one stationary point, and -1/2, 4 is the other stationary point. Now it says to determine, let me shrink this down here a little bit so you can see our work in both places. Determine whether each stationary point is a maximum or a minimum. So we know what the stationary points are, but we don't know which one is the maximum and which one is the minimum. So what we're going to do is we're going to take the second derivative. This is called the second derivative test. So you just take the derivative again, but you don't take it, you take the derivative of your first derivative, which is why it's called the second derivative. So y double prime. So you might multiply the 2 to the front, that gives you 24. Subtract 1 from the exponent gives you x to the 1. Again, the derivative of a constant is 0, so we just get 24x. Now we're going to plug into the second derivative our x values. So we plug in 1/2. 24 times 1/2 is 12. Now 12 is a positive value. So notice I put these little positives here. It's a smiley face. Smiley face means that this particular set of coordinates, the 1/2, 2, is a minimum. It's at the bottom of the smiley face. When we plug in the negative 1/2, we get negative 12, which is less than 0. It is negative, so we get this frowny face. And so this set of coordinates, the negative 1/2, gives us the maximum. It's at the top end of the frowny face. Here we have part B, the graph of y equals x squared minus x plus 1 is shown on the grid. So they graph it for you. Now they want you to draw a suitable line solving the equation x squared minus 2x minus 2 equals 0. So notice we are not solving this algebraically, we are solving this graphically. So what we want is we want this left-hand side to look like the original. The original is x squared minus x plus 1. So far we got the x squared there, we got the x squared on this first term. That part is good. Now we have a negative x here and we have a negative 2x here. So we need to change it to a negative x. So we're going to add x to both sides. So when we add x, that makes it negative x, and we put the x on the other side. We also want a plus 1, and right now we have a minus 2. So to get a plus 1 on this left-hand side, we need to add 3 to both sides. So when we do that, when we add the x and the plus 3, notice the left-hand side is exactly the same as the original, meaning it's this graph here that was already given to us. And when we have x plus 3 on the other side, that is going to be our suitable line. Y equals x plus 3. So it crosses the y-axis at 3, has a slope of up 1 over 1. So be careful that you're going up 1 by scale, not just by little box. So 3 to 4 is going up 1, and your over 1 is all the way over here. Here's your 1 at. So you go up 1 over 1 by the scale values, not by these little boxes that can be misleading. So up 1 over 1 is here. Draw your line through it. Notice these little red marks I put on it. That is the intersecting point. That also happens to be your answer to this equation. And it intersects, and I put a negative 0.75. For this one over here, I put 2.72. Notice the windows, they give you a window of acceptable answers, and mine are within both windows. So those are good answers. And that takes us to the end of this test. So again, this was IGCSE May-June series paper 2020. This, by the way, is a part of the new syllabus cycle for IGCSE, which is why maybe you weren't used to seeing that derivative stuff. That's part of the new content for the new syllabus. And this was paper 43. I hope that this was helpful to you so that you can learn how to do these questions and be successful on the exam. And always thank you for joining me, and hope to see you again next time.